Hello everyone, welcome to the session on digital electronics. In this session, we'll be discussing about decoders. In this session, we will see what we mean by decoders, how to make use of decoders, and also we will see the different types of decoders such as BCD to decimal decoder and BCD to 7-segment display decoder. Friends, as you know that you are viewing this session on my YouTube channel, Learn with Prakash Khanade, and do subscribe to the channel to see many videos on the subjects of electronics and computer science. So let us start the session with the question, what we mean by decoders. Decoder, you can say that it is a digital circuit. It is in fact a combinational circuit, and this circuit is used to decode the input coded information. So decoder at the input will have a coded information, and at the output it will produce an output where the information is in understandable form. So decoder is a combinational circuit, and this circuit will perform exactly reverse operation to that of encoder. Because in case of encoder, we have seen that encoder is a circuit which will accept the information that is in understandable form, and it will convert the information into coded form. But decoder will perform exactly opposite to that of encoder. And therefore, in the decoder, at the input, we have some coded information, which is in the form of n inputs. And at the output, we will get the information that is in understandable form, which is 2 raised to n output. So you can say that the decoder will have the input, which are n inputs, and there are 2 raised to n unique outputs. So for each combination of the input, one can easily observe that only one output will go high. Decoder, one can say, is similar to that of a demultiplexer circuit. But as we have seen in case of demultiplexer, that the demultiplexer will have some data input, and that data is being passed on to one of the output. But in case of decoder, as such, we do not have any data input. What we have is the coded input, and that coded input is being passed on or is being converted into understandable form at the output. There are different types of decoders. Say, for example, we can have BCD to decimal decoder, where the input information is in BCD form, that is in coded form, and at the output, it is being decoded in the decimal form. There is another decoder circuit which is very popular, and this decoder circuit is being called as a BCD to 7-segment decoder. So at the input of this decoder, we have a BCD code, and at the output, we will get a code where the corresponding decimal number can be displayed by using the 7-segment display. Decoder circuits are very widely used in various applications. Say, for example, in analog to digital converter, we need to make use of the decoder circuit. Also, the central processing units of computers, arithmetic and logic units of computers. And in many industrial applications, you can think the decoders can be used. So whenever you want to convert the one form of information into another form, or the coded form of information into understandable form, then you can always think of making use of decoders. Now we will go first of all the BCD to decimal decoder. So as shown in this diagram, this decoder will have inputs which is BCD input, which is in the form of BCBA, and there are 10 output lines from 0 to 9. So you can say that the output is the decimal output. This decoder circuit will have enable input or strobe input, and normally this enable input or strobe input is active low, and therefore it is indicated by a bubble. So BCD to decimal decoder will convert the input BCD information into decimal output. So as it is shown in this figure, this decoder will have the 4 inputs that are the BCD inputs, and there are 10 decimal outputs. The enable input or the strobe input of this IC must be active low. So whenever you want to make the use of this IC, then it is necessary that the G must be equal to 0. Many times you will find that this decoder is called as one of 10 decoders, since there are 10 output lines, or sometimes it is also called as 4 to 10 decoder because there are 4 inputs, BCD input, and 10 outputs, and therefore it is also called as 4 to 10 decoder. One can easily observe that this decoder is being available in the IC form, and IC 7445 is a very popular BCD to decimal decoder. Now we can easily go for the design of the BCD to decimal decoder. As we know that this decoder will have the 10 outputs from 0 to 9, and it will have the 4 inputs D, C, B, and A. The strobe input or enable input is active low, and it must be equal to 0 for proper working of the decoder. Now we can easily construct the truth table for this decoder. The inputs are DCBA and another input G that must be equal to 0. So whenever the inputs DCBA are 0, 0, 0, 0, then one can easily observe that only the output line 0 will be active high, while rest of the outputs will be equal to 0. When the input is 0, 0, 0, 1, then the output 1 will go high and the rest of the outputs will be equal to 0. When the input is 0, 0, 1, 0, then the output line 2 will go high and the rest of the outputs will be equal to 0. When the input is 0, 0, 1, 1, then the output 3 will go high and the rest of the outputs will be equal to 0. When the input is 0, 1, 0, 0, then the output line 4 will go high and the rest of the outputs will be equal to 0. When the input is 0, 1, 0, 1, then the output line 5 will go high. So whenever the output line 5 will go high, then it will indicate that the input BCD code corresponds to the decimal 5. In this way, when the input is 0, 1, 1, 0, then the output line 6 will go high. When the input is 0, 1, 1, 1, then the output line 7 will go high and it will indicate that the input BCD code corresponds to the decimal number 7. When the input is 1, 0, 0, 0, then the output line 8 will go high and the rest of the outputs will be equal to 0. And the final possible combination for the BCD input is 1, 0, 0, 0, 1, 0, 0, 1, and for this input the output decimal 9 will go high and the rest of the outputs will be equal to 0. So just by checking the corresponding output line, which one is high, we can easily tell what can be the BCD code. So here one can easily understand that the input BCD information is being coded into the decimal form. That is, the coded information is being converted into the understandable form, and therefore this circuit is a kind of decoder circuit. Now from this truth table we can write equations for the output. Now when you check the column for the 0 output, then one can easily observe that the 0 output is 1 only when the inputs DCBA are 0, and therefore we can write the equation for 0 is equal to D bar, C bar, B bar and A bar, or D dash, C dash, B dash and A dash. Now in this way we can write the outputs for 1 as D bar, C bar, B bar, A, that is 0, 0, 0, 1. Then for 2, 0, 0, 1, 0, and therefore D bar, C bar, B, A bar. For 3, D bar, C bar, B, A. For 4, it is 0, 1, 0, 0. Therefore, for 4, we can write the equation D bar C, B bar A bar. For 5, it is D bar C, B bar A, 0, 1, 0, 1. For 6, it is 0, 1, 1, 0. And therefore, the equation can be D bar C, B, A bar. For 7, it is D bar C, B, A. For 8, it is D, C bar, B bar, A bar. And for 9, it is 1, 0, 0, 1, and therefore the equation can be 9 is equal to D, C bar, B bar, A. Now, if you look at the equations, then one can easily understand that whenever you want to construct the circuit for BCD to decimal decoder, then such circuit can be easily constructed by making the use of AND gates. So now we can draw the logic circuit for BCD to decimal decoder. So here we require 10 AND gates, and every AND gate will have 4 inputs. So the first AND gate will have the input D bar, C bar, B bar, A, and its output will be decimal 0. The second AND gate will have the inputs D bar, C bar, B bar, A, and its output will be decimal 1. So in this way, one can easily observe that according to the equations, the inputs of the AND gates will get changed. Say for example, this AND gate will have the input D, C bar, B bar, A bar, and its output will be 8. And the final AND gate will have the input D, C bar, B bar, A, and its output will be decimal 9. As I told you, IC 7445 is a very popular IC, and such circuit is being made available in this IC. So whenever you want to make the use of BCD to decimal decoder in any logic circuit, then you can make the use of this IC. Now we will go for another decoder, and this decoder is also a very popular decoder, and it is being called as a BCD to 7 segment decoder. So BCD to 7 segment decoder, you can say that it is a decoder circuit where the input information is in BCD form, and it will convert this information in appropriate output for segments to display the input decimal digit. So 7 segment display is a special device where the 7 LEDs are arranged in the shape of 8. So this is the first LED, this is the second B, the third one is the C, the fourth one is the D, E, F, and G. So there are 7 LEDs and they are arranged in the form of 8. And these LEDs are arranged such that we can display any number from 0 to 9 by making the use of these LEDs. So BCD to 7 segment decoder will actually convert the input BCD information in such a fashion that whenever the BCD input is 0000, then the number 0 will get displayed on the LED display. This decoder will have the 4 inputs that are the BCD inputs D, C, D, A, and it will have 7 outputs because these 7 outputs are connected to the 7 segment display. So these outputs are from A to G. The 7 segment display, as shown in this diagram, one can easily observe that there are 7 LEDs, and these LEDs are arranged in such a way that they can display any decimal number from 0 to 9. One can easily observe that there are 2 types of LED displays that are commonly used. The first type is being called as a common anode type. So in this type of the display, all the anodes of the LEDs are made common, and the cathode terminals are made available as the A, B, C, D, E, F, and G terminals. So whenever we want to make the use of cathode anode type LED display, then the positive terminal of the battery is connected to the common anode. And whenever we connect a 0 to the A input, then that corresponding LED will get displayed. So we need to apply low signal or 0 signal to the individual LEDs so that that particular LED will get displayed or it will light. Another type of the LED display is being called as a common cathode type. So in this type of the display, all the cathode terminals of the LEDs are made common, and the anode terminals are connected to A, B, C, D, E, F, and G. So in such a case, one can easily observe that the cathode is being connected to the ground or negative VCC. And whenever we want to glow the LED, then we need to apply the positive voltage or 1 voltage to the corresponding LED. Now let us go for the BCD to 7 segment decoder. IC 7447 is a very popular BCD to 7 segment decoder IC. And this IC, as shown in this diagram, will have the 4 inputs DCBA, and it will have the 7 outputs. So these 7 outputs are connected to the 7 segment display. So for example, here we are using a common anode type display where the positive terminal is being connected, the common anode terminal is being connected to the positive VCC, and these are all the cathode terminals, and these cathode terminals are connected to the output of this decoder. One can easily observe that this IC 7447 has many other terminals such as LT, and this is being used for the testing of the LEDs. BI, that is blanking input. So whenever we activate this input, then all LEDs are blank. Or we have a RBI, or that is being called as a ripple blanking input. This IC also has a G or enable input, and this input must be equal to 0 for proper working of the decoder IC. Now we will go for the truth table of BCD to 7-segment decoder. So when the input BCD information is 0000, then we know that the number 0 should be displayed. But in order to display the 0 number, one can easily observe that the LEDs A, B, C, D, E and F must glow, and only the LED G should not glow. And we know that this is a common anode type LED display, and therefore whenever we want to glow the LED, then that corresponding LED must get a 0 at the input. And therefore from this table one can easily observe that A, B, C, D, E and F are 0 and only G is 1, and therefore the number 0 is displayed on the LED display. When the input is 0001, then the number 1 should be displayed. But in order to display the number 1, the LEDs B and C must glow, and the rest of the LEDs should remain off. And therefore here you will find that in the code, the B and C will have the 0 input, while rest of the outputs will be equal to 1. And therefore the number 1 will be displayed on the LED display. Similarly, when the input information is 0010, then the number 2 must get displayed. And in order to display the number 2, the output must be 001010, so that the number 2 will get displayed on this LED display. Similarly, when the input information is 0011, then the number 3 must get displayed. So in order to display the number 3, the LEDs F and E must be off. So in order that the LED E and F must be off, the output for E and F must be equal to 1, and the rest of the outputs must be equal to 0. When the input information is 0100, then the number 4 must get displayed, and therefore the output for the decoder can be 1001100, so that the number 4 will be displayed on the LED display. When the input information is 0101, then the number 5 must get displayed, and in order to display the 5 on this LED display, it is necessary that you should get the output of the decoder 0100100. Whenever we want to display the 6, then the corresponding LEDs must glow, and therefore in order to display the 6 on this display, the output of the decoder must be 1100000. Whenever you want to display the 7, and when the input BCD code is 0111, then in order to display the 7, the LEDs A, B and C must glow, and the rest of the LEDs should remain off, and therefore the output code that is being expected here is 0001111. In this way, for the input BCD 1000, the number 8 must get displayed. And in order to display the number 8, one can easily observe that all LEDs must glow, and therefore the output of the decoder must be equal to 0000000. So all LEDs should glow whenever the input code is 1000. And in the last case, when the input BCD input is 1001, then in that case, the output code for the decoder must be 0001100 so that the number 9 will get displayed on this 7-segment display. So as I told you that IC7447 is a IC in which this BCD to 7-segment decoder circuit is available. It is also possible that you can design the circuit on your own by making the use of this truth table. But if you want to design the circuit on your own, then you need to make the use of Karnaugh map. And by making the use of Karnaugh map, you can simplify the equations and then you can construct the logic circuit. But IC7447 is a popular BCD to 7-segment decoder IC, which can be used whenever you want to make the use of this decoder in any logic circuit. So thank you friends for viewing the session. Hopefully you have understood what we mean by decoder and how to make the use of the different decoders in the logic circuit. Thank you all for viewing the session.